So what's the benefit of you and I adding some fault tolerance for the default gateway that a user like Bob is going to use? Well, the reality is that most traffic that leaves a computer on our networks today is destined for something other than the local network. And so if their default gateway goes down and we don't have some redundancy built in, their network traffic at that point is going to stop as well. So the first example of an FHRP protocol, first hop redundancy protocol, that I'd like to share with you and walk you through is HSRP from Cisco. HSRP stands for the Hot Standby Router Protocol. It is pretty darn simple to set up. So let's look at a game plan of what we intend to do, and then we'll go right to the lab to implement it and verify it. And it just so happens that the topology we used in our previous video, as we talked about the overall concept of an FHRP, this is going to work perfectly for a lab on HSRP, the Hot Standby Router Protocol. All right, so let's do this. We have a PC in the lab sitting at 10.16.0.10, and currently, let me go ahead and erase this. Currently, its default gateway is .1. So currently its default gateway is this 1/0 interface on R1, which is 10.16.0.1. And R2's address on this network is 10.16.0.2. And this virtual address of .3 won't show up until we configure on each of these interfaces on router 1 and router 2 the HSRP protocol. So let's go over to the virtual lab. If you're sitting at a computer watching this, go ahead and click on the link for the virtual lab and join me side by side as we configure and verify HSRP. All right, so here in the lab environment, we're going to DCNUG. That's our management computer. We'll go ahead and supply the password and log in. In the upper left-hand corner, we have PuTTY, so we'll go ahead and launch that. And then within PuTTY, over here on the far left, there's a sideways tab for servers. If we select that, we want to open up a tab to R1, and servers again, open up a tab to R2, and we are good to go. All right, so a great practice that we want to get in the habit of doing is verifying and making sure that when we go to the interface, we want to make sure we're configuring the correct interface. So if we're not sure, if we know it's the 1016 network and we forget which interface it is, we can do a show IP interface brief. Not a bad idea. Verify the interfaces are up and also verify which interface we want to go into. So we want to work with gig 1/0, and that's the interface where we want to enable the HSRP protocol. So we'll go to configuration mode, interface gig 1/0, and to enable Hot Standby Router Protocol, what we'd do is type in standby. That's the keyword to enable it. Press the question mark. Then there's several options, but the core one I want to share here is the group. So we're going to specify an HSRP group number. Now, if this is VLAN 10, you can put a 10. If you just want to use the number 1, it's just a number that's associated with this standby group. So we'd put in the number, put in a question mark after a space, and then we'd specify the next parameter. So we're going to put in the keyword IP. We're then going to specify our virtual IP address. Let's take a look at our topology. We want this virtual IP address to be 10.16.0.3. So that's the IP address we're going to put in the interface configuration for the standby protocol. So we'll put in that address, 10.16.0.3, press enter. And there are several other options that we could mess with or tweak or tune, but that's the basics to get it going on this router. And then we do the command again over on router 2. Now, in just a few moments, we should get a console message showing us that this router has looked around, saw there's no other peers, and is going to go ahead and become active for that virtual address that we just assigned. So I'm willing to wait for a moment. Let's go ahead and wait for the console message. Ah, there it is. All right, so we have a state change, gigabit 1/0. Group 10 state went to active. So this router for that interface is now active for that standby group. We can verify that with a show standby and press enter. So here's our group number. Here's the virtual IP address. The virtual IP address also has a unique MAC address associated with it, and that MAC address is currently in use by this device because this device is active. This router is active. Down here it says the active router is local. Great, that means it's us. And it also says the standby router, Mr. Backup, is unknown. That's because we haven't enabled HSRP yet over on router 2. Let's do that next. So we'll go over to router 2. On router 2, we'll do a show IP interface brief. Just like that. We'll verify that we're going to work with the correct interface, which is gig 2/0. Same network segment. Go into configuration mode. Go into interface gigabit Ethernet 2/0. Little copy paste there. And then in interface config, we'll type in standby. same group number, and the same IP address of 10.16.0.3. Press enter. In a few moments, we'll see that this device is going to take the role of standby, the backup unit, if you will, between the two in supporting that virtual IP address. So we'll wait for that message that indicates it's happened. There we go, perfect. And then we'll do a show standby. We can also do a show standby brief. This gives us a Reader's Digest version. So it's interface gig 20, group 10. Current state of this interface is standby. The active is over at 10.16.0.1. The local device, this device we're looking at, is standby, and that's the virtual IP address. So now, if we were to go to a client, and good news, in the lab we have one, we have a client PC over on the right that we can use. We can test this to verify that it works. So in our topology, we're going to go to this PC right here, which has the IP address of 10.16.0.10, and let's verify, first of all, its default gateway, just to verify that we have our pieces in place, and then we'll verify the HSRP is working as planned. So we'll click on the link for the PC in the virtual lab, and we'll supply the password there as well, and log in. So here we'll bring up a command prompt. Any way that you want to is great, here on this Windows 10 computer. And if we do an IP config, it says my IP address is 10.16.0.10, great, and the default gateway is 10.16.0.1. Now, that is currently pointing to R1, and just as a test, I think we ought to do this. Let's do a ping space -t for keep going, and let's ping an IP address off the local network of 192.168.1. Let me think about what's a valid IP address over on the right-hand side of R1 and R2. Let's do 22. Let's ping that address, and that's just ping and ping and ping. It's using R1 as its default gateway. But just as a verification, before we point to the virtual IP address, if we go back to our management computer and we go to R1 and we go into interface configuration mode for interface gigabit 1/0, just washed my hands and can't do a thing with them. And we go to the interface gig 1/0 and we do a shutdown. Let's do that. So by shutting down this interface, that effectively means that the IP address at 10.16.0.1, which was Bob's default gateway, is down. And that means no more packets off the local network for Bob because he's pointing to that as the default gateway. Let's go back to the client PC for a moment and just verify that the pings have stopped. There we go. No longer is Bob a happy camper. Bob can no longer get off his local subnet. So I've got destination host unreachable. I'll do a Control-C. And now let's do this. Let's go in and let's change Bob's network configuration and have him point to .3 as the default gateway, which is the virtual IP address being supported by HSRP. There's a few ways of changing the IP address on a Windows 10 computer, and those options change as Windows moves to newer versions of Windows 10. On this lab PC, a very quick way of getting there to change the IP address is to right-click on the Windows icon, bottom left-hand corner, and there's an option for network connections from that menu right there. So let's click on network connections. Here's the network 1016 interface. We'll just double-click on that right here in the middle. And click on properties, and then we'll double click on TCP/IP version 4, and let's change the default gateway to .3, just like that. And we'll click on OK, and click on OK, and that is great. Also, I'm going back to the command line because I always like to verify. If we made a change, I like to make sure that the change we think we made, we actually made. So now we have default gateway at 10.16.0.3, fantastic, and at the moment, that's being supported by R2 because they shut down gig 1/0 and over on R1. So if we go to R2 and we do a show standby and press enter, for gig 2/0, the virtual IP address is 10.16.0.3 and the active virtual MAC address is this guy. It's currently in use by R2 and the state of R2 is currently active. Great, let's do this. Let's go ahead back to the PC, and on the PC we'll just do a continuous ping again. Great. So the moral of the story is that HSRP, Hot Standby Router Protocol, is an example of an FHRP, a first hop redundancy protocol. And the bottom line is that we're providing some redundancy for that default gateway that users can use so that if one single router fails, the other one can pick up and continue forwarding packets on behalf of the networks and the users on those subnets. So have some fun in the lab practicing and verifying HSRP. It's there for your use. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.